Today I'm going to go through replacing a power supply and trying to understand the issues, triaging the problems with my NAS. A couple days ago I tried connecting to my network attached storage box here, the Synology DS916 Plus, and no luck. Checked out the power supply status LEDs. Ignore the cats running across the bench. And this status light right here was blinking in concert with an LED that was located here within the power brick. So you'd see light turn on, light turn off, light turn on, light turn off. That's typically indicative of some sort of power issue where the device is trying to draw energy from the power supply, and then the voltage immediately collapses, goes into self-reset, and then attempts again to power up in an infinite loop there. So I pulled the power out. I was able to power up my Synology NAS from my DC power supply here on the right hand side, gave it 12 volts with a necessary current. We'll talk about those values in a second, and it worked just fine. So can very confidently say that the issue resides inside of this AC to DC switch mode power supply. So we'll be going into some of the details of what's required, what are the specs, the advertised specs of this power supply, and what should be good enough for NAS, and what you might have laying around at home that you can use yourselves and wire up and give yourself a replacement power supply. And the output, that's what we care about. That's what our NAS device here is going to consume. That takes 12 volts, and this power supply can provide up to 8.3 amps. It's a lot of power actually for a DC device, and you need that because you have 4 spinning hard drives in here. Each one of these consumes a good chunk of power, so it's important that you have a very good high quality power supply. And this video is not for everybody. If you have a NAS that is having power issues like I'm having, and you're not comfortable with working with electronics, with soldering, with wiring, the easiest thing to do is to just go online and buy the replacement power supply. You can buy them on Amazon. You can buy them, I believe, directly from Synology, the OEM ones. And this is a very good one, very high quality power supply. I'll show you some details about the construction. Costs on the order between $100, $125, or $150. With those details out of the way, and I'll post links to the available power supplies if you'd rather just buy your own. The important bit is just the electrical spec and then the hardware interface. So, this version of the Synology uses a 4-pin DIN connector. I'll have some high-resolution photos of this, but it's a circular connector, 4 pins. The 2 pins on the top, I call the flat side of the connector here, where the divot is. Those 2 pins are hot, and the 2 lower pins, those are ground, and your outer circular connector is also tied to ground as well. So 12 volts in ground, and capable of spitting out up to around 8 amps at 12 volts. So again, good amount of energy coming down these lines potentially, and that could have been what caused some of the failure here. I've had this device for a handful of years. This was the original power supply with the NAS, and I was hoping to disassemble this and try and find a root cause and find the smoking gun, so to speak. Unfortunately, it's very tightly constructed. There's not a lot of things you can disassemble easily or look at easily. There's a lot of silicone adhesive meant to keep things from buzzing and shaking. Again, speaking to the good quality of the assembly here. So a good amount of thought put into not only the mechanical motions of devices, but also the thermal design. There's a lot of thermal paste here that's placed to conduct heat to the metal shield around, and then of course the EMI, EMC aspects of having this metal shield keeps all that switching noise inside the device and prevents it from leaking out. So great job, Synology, in terms of buying your power supplies from good vendors. Unfortunately, this one didn't last very long, so we wish that room for improvement can be figured out. But thankfully, I was able to get the connector and the cable removed from this power supply, replacement for this power supply. I happen to have an old Microsoft Xbox 360 power brick hanging around. And this is a beast of a power supply. Let's take a look here at the input-output capabilities. Again, this is international, or I'm sorry, this is not international. This is only 100 to 127 volts. So can't take this overseas and plug it in. It pulls 5 amps from the wall. So make sure, if you're pulling that much energy, your breakers can supply all the collective current on your line in your house. And yes, 47 to 63 hertz. So interesting ranges there. Output DC total 203 watts. So this can output 203 watts when you combine the two rails. There's two rails here. There's a 12 volt rail, and it can output 12 volts, 16.5 amps, which is double the original capacity of the power supply that came with the NAS. And that's what you care about. So if you want to see what do you have hanging around at home, first thing is, all right, is it 12 volts? Great. And the second question is, you need to at least match or go beyond the spec of what you're trying to replace. You do not want to go below. Manufacturers margin things in. You can make arguments around, oh, it's fine. You can go down to 7 amps, 6 amps, 5 amps, maybe. Depends on your hard drives. It depends on what you're doing on the NAS, what sort of CPU compute you're doing. And if you're spending money on a NAS, you're probably the type of person who doesn't want to be taking risks with their data, so you shouldn't be taking risks with your power. All the more reason to just buy a replacement if you're not completely comfortable with electronics, with circuit theory, and understanding how power supply rails work. So there's a 12 volt rail, 16.5 amps, great. We're not going to use all that energy. It's capable of outputting more current, but the device won't be pulling that much, which is fine. And then there's a 5 volt rail, 1 amp capable. So this is a pretty versatile little power supply. If I spin it around here, you'll see there's an LED here, an LED indicator. It either is orange or green, and that lets the user know whether or not it believes the computer's on or not. So back in the Xbox 360 days, when your console was idle, this would be orange, and when you press the power button on the console, this would turn green, and you can actually hear the fan spin up to handle the cooling required. On the other end here, I've already cut the connector off that used to plug into the Xbox 360, and there are 4 different color wires. There's a red, a blue, which I've twisted together here, these yellow wires, and these black wires. So black is ground, yellow is 12 volts, red is 5 volts, and blue is your power supply enable line. If you pull this high to 5 volts, meaning you short the blue to the red, that is the control signal to tell the power supply to turn on the 12 volt rail. So we can do a quick demonstration here and check out the power supply, make sure it works. Okay, so time to test the power supply out. And you can see with the green LED lit, we have a voltage of 12.239 volts. I have my Fluke 289 connected here with these clips. I'm going black to black, and I'm measuring the yellow lines here. So that's giving us our 12 volts. And you'll see if I disconnect the red from the blue line, first off, we get the yellow line, the yellow light. And you see the voltage here slowly collapsing. That's just the parasitic, or not parasitic capacitance, but the actual capacitance inside the power supply slowly draining, and it'll eventually come down to 0 here. Also, to note, if I move my measurement probe here from the yellow line, if I move it to the red, we'll now measure the voltage. It's at 5 volts. So the red's always on at 5 volts. Yellow is gated by the blue line. That's our power enable. And if we look at the power enable line, try and measure the voltage there, we see 0.02 volts, so 22 millivolts there. So we're pulling that high to turn on the device, and likely that's actually the gate of a FET, and when we pull that high, we're turning a FET on, allowing the power supply to actually turn on. Okay, so here is the end of the Xbox power supply. So just to recap, yellow is positive 12 volts, black is ground. This is the shield braiding, which I'm also going to attach to ground. And then red is 5 volts, blue is enable. Here is the Synology power supply cable, which we're going to splice into it. So this is the end after the power brick on the Synology. So this 4-pin connector plugs into the NAS, and here we have a braid and a white wire. That's it. So the shielding of the connector and the 2 return pins connect to the braid. I tested that out with the multimeter. And then the white wire goes to the 2 top pins here, the top left, top right. Those actually carry the 12 volt power. So the way that the splice is going to work is that the white's going to go to the yellow, and the braid here is going to go to all the black wires and the braid here. And then to not lose the functionality of being able to power this on and off, we'll have the 5 volt line and the enable. I'll go through this toggle switch, and I'll do kind of just a mounting job here in line with the harness. Best way for strain relief is if you bring them in coming together like this, and try and strain relieve them together. This way there's no way that the wires can get pulled and the joints take any of the force. So we'll have a switch. I'll strain relieve them here with some zip ties and some tape. Do all the connections, and then we'll give it a try. Alright, so we have our fully assembled power supply. We are currently unplugged, so no danger or risk here. We have our splice here and the switch on the power enable. So currently we're in the off position. That's how you go on, off, and that's spliced into the black wire, which is the Synology power connector here. So we're just going to do a buzz out and make sure there's no shorts across the rails. So first off, we want the shield of the Synology harness to be attached to the grounds, which it is, and not attached to the powers. Now you notice that beeped initially when I touched the power pins. That's because of the circuitry inside the power supply and charging up a capacitor. Sometimes, depending on the polarity, you always want to. That's why you always want to test these things in both directions. Again, ground, ground, hot pin, and it beeps initially, hot pin. And we're actually charging a capacitor. So an uncharged cap will look like a short right when you touch it, and the multimeter will see that inrush of current. It'll think it's a short instead of just a charging cap. And as the voltage builds up on the capacitor, less and less current will flow, and the multimeter will start reading that as a resistance. But the ground pins are good, and the hot pins are not attached to ground, which is fantastic. So again, you leave it there for a second on your hot pins just to make sure that your cap charges the way you want, but the ground pins are actually shorted. So that's great. Alright, let's power it up. So I'm going to plug it in. We should see a yellow light, and we do. And if I flip this switch, that yellow light should turn to green. And I hear a fan whirring inside the power brick, and I also feel the air coming out. So now let's switch to DC volts and do a measurement here. Okay, so we got the power supply running, green LED, the enable switch is on. We're in DC volts here on the Fluke. Okay, so the 2 power pins are to the left and the 2 ground pins are to the right. You want to be careful here, you don't short anything out. So we go to the top left power pin, that's positive 12.04 volts. The bottom left power pin, positive 12.04 volts. Then we should see 0 volts in the ground, which we do, less than 1 millivolt. Less than 1 millivolt. Beautiful. So the power supply is working as intended. So all that's left to do is plug it into the NAS and see how it performs.